What is up, guys? Fahir here from AwesomeTuts.com. Moving forward with our more complex topics, we have singletons. Now, what are singletons? Well, singleton is a design pattern that allows us to only have one instance of a single class and use it to access all of its public functions and variables. To make this more clear, I have this singletons class and I have the sender class, and both are in this scene attached on the tester game object. So I have the sender and I have the singletons class. If, for example, inside of the singleton class, we have a public void do something function, and here I am going to print executed from function. If we want to execute this function from this script, we need to do the following. We need to do game object, find the game object with the given name, and let's say the name of the game object, if we go here, is tester. So we need to paste the exact name. So tester game object, paste it here. We need to say get component and get the singletons component like this, and then do something or call the do something function. Now, bear in mind, I do know that both of these scripts are attached on a single game object, but if it's easier for you to understand, I am going to create another separate game object and put the sender script on this bad boy over here. Because we can use also get component directly because it was attached on the same game object. My point is that we need to use get component either with game object find or simply using get component. And if we go in Unity and if I hit the play button, we will see that executed from function is printed in the console. And it is printed from the sender public class. Now, of course, you can do something like private singletons, and you can name it whatever you want, singletons or sin, for example, however you want to name it. And then you can game object find, singleton is equal to game object find, get the component, and you get the component like this, and then you call singletons.do something, and voila, you are good to go. But you can do something like this. You can also do singletons_2, for example, and you can copy and paste this code here, and you can say singletons_2 is also equal to game object find the tester game object, and then singletons2 do something, and you will see 2 times executed from function being printed inside of Unity console. So if I go here and if I hit the play button, you will see 2 times. So where or what does this have to do with a singleton? Well, let me show you now how much easier it is. We don't need all of this code. I'm going to leave it here and then I will delete it. But with a singleton pattern, we can do something like this. So we can go here and we can create a public static singletons, and I can name it instance. And notice here, this is a declaration of a variable of the same type as this class, which means we are creating an object. We know that when we have a class, it is a blueprint for creating objects. So we can create multiple objects of a single class. That is, or a good example is if we have a car class, we can create multiple cars. So we can create a BMW, we can create an Audi, we can create a Mercedes-Benz, all that from a single class. But with a singleton pattern, we can only have one instance, which means if we use a singleton pattern on our car class, that means that we can only have one car created from that class. And right here, I can create void make singleton like this. And here we are simply going to test if our instance, so if instance is not equal to null, then we are going to say here instance is equal to this, like this. So if it's not equal to null, then, or actually if it's equal to null, meaning if the instance is not pointing to anything, we know that when we create a class, The class is actually an object from a class. That object is pointing to a spot in memory. So this right here is an object from this class right here. Now we are creating it within the class itself. So this instance is pointing to a spot in memory, and this is a spot in memory in your CPU. So it is pointing to that spot. But if this instance is equal to null, if this right here is true, it means that this is pointing nowhere. So it's not pointing here. It's not pointing to a spot in memory. When we say it is equal to this, now this refers to this class itself. So it is referring to the class. It's the same as if we say new, so we're creating new object, so singleton instance is equal to new singleton, except here we're saying it's equal to this, which means this right here is referring to this class itself. Now we can call this in the awake function. So we can say here void awake. And this is usually where you are going to put the code to create a singleton. Now this right here is not yet a singleton pattern. I'm just going to show you how easier it is now that we have a static. And notice the static. What does static means? Static means that we don't need to use get component as we did here. So we don't need to use get component and then dot do something in order to access this public void do something. Instead now, because we have this static, we can say singletons dot instance, because this is the static variable, dot, and we can call any public variable or public function. So if I go back here, we don't need all of this code. Notice all of this code goes away. So 2 lines of code here, and 2 more lines of code here, that is 4, 2 more lines of code here, that is 6 lines of code that we don't need to use. Instead now we can simply say singletons dot instance dot do something, and this will execute the do something function that is right here. If I go back in my Unity editor, let me first clear the console. I am going to hit the play button. Notice in the console, executed from function. So our do something function is executing. It is printing the code, or if here we have some other code, for example, to start the game or to load a screen or something like that, it will call that code and execute that code. You see how easy it is using singletons? So we don't have to use all of those 6 lines of code in order to have or to execute this function by using get component, so on and so forth. Now, this still is not a singleton pattern. A singleton pattern means that we can only have one instance of this class. So here, instead of if instance is equal to null, I'm going to say if instance is not equal to null, I'm going to destroy the game object. Notice here, I'm going to destroy the game object. Else, if instance is equal to null, I'm going to say instance is equal to this, but now I'm doing that in the else statement, and I'm going to say don't destroy unload game object. What does this here mean? Why don't destroy unload, and what am I doing here? First of all, if we go from one scene to another scene, and notice I have 2 scenes here. I have created another scene. Notice here, this another scene only has this game object, which has this receiver game object attached, which is a script actually attached on this game object. Now, in the sample scene that we are currently in, we have the tester game object who has the singletons script. And here I can simply name it singleton object. So it is more clear. Pay attention, our singleton object is not in another scene. And notice I've put here the text so that we can see that we are actually in another scene. Pay attention to the hierarchy panel. We have the main camera, canvas, event system, and game object. We do not have this singleton object inside of this other scene. And if I go here in the sender, I am going to invoke after 3 seconds this function that will load this other scene. And here I'm also going to comment out this make singleton so that we don't make it a singleton, and we are going to go to another scene and I'm going to demonstrate something. So if I hit the play button, notice currently we are in the sample scene, we have the singleton object. Now we are going to go to another scene as we just did. You see here the scene is loaded. And notice here we have the main camera, we have the canvas, we have the event system, we have the game object, but we do not have our singleton object. That means that whenever we go from one scene to another scene, all game objects that are in the previous scene are destroyed. So they are destroyed. How do we prevent that? We prevent that by calling this don't destroy unload, passing the game object, and this game object variable refers to the game object who holds this script. In this case, singleton object is the one who is holding this script. So now, since I have uncommented make singleton function, which will make this a singleton, it will execute this line of code, don't destroy unload. If I go back here and I hit the play button, pay attention now. So we have here our singleton object. When we go to another scene, bam, you see it here. We have another scene, we have the main camera, canvas, event system, object or game object, and we have this don't destroy unload, which holds the singleton object, which means we have it. It can move from one scene to another scene. What does this mean? It means that I can go inside of the receiver class here and I can do something like singletons.instance.do something. And this class is attached on the game object, which is in the scene that we load or in another scene. So if I hit the play button now, notice nothing is printed in the console. When we move to another scene, bam, executed from function, because here on this game object, we have the receiver script, which is this one right here, which calls the singletons class, which is this one right here, and the instance, so receiver, I just turned it off, and the instance, which is the static variable, which is the static reference to the class itself, and dot do something, which is calling this function. Now I am demonstrating all of this with a function, but this also works with a variable. If you have a public variable here, public int, bool, string, whatever, you can do the same thing. So you can call it right here. So you see how this works? And in order to show you, because we are using a singleton pattern, now this right here is a singleton pattern. We are testing if the instance here is not equal to null, meaning we have a duplicate game object. How do we have a duplicate? Well, let's say if I go in another scene. So come on, Unity, I'm in another scene and I'm going to create an empty game object. I'm going to type here singleton tester. So singleton tester, and attach our singletons script on it. So this will be a duplicate if I don't do this. So if I go here in the singleton and I don't call this don't destroy unload game object, notice what is going to happen. So I'm going to go in the sample scene and here it is. We have our singleton object and I'm going to hit the play button. And notice now after 3 seconds, we will load our new scene, another scene, we have it here, and notice we have here a singleton tester as well. So we have the singleton object and we have a singleton tester. So we have two game objects holding this same script. And we don't want that. And also, if I go inside of our receiver and I using Unity engine.event systems, or actually scene management, and here I'm also going to create a function like load new scene, something like this, and I'm going to say here load new scene, and I'm going to load our sample scene. So sample scene, and I'm going to do the same thing here. So after 3 seconds, I am going to invoke this function to load our sample scene so that we can go back to our sample scene, which is this one right here. Now pay attention in the hierarchy for the sample scene. We have the main camera, We have here our singleton object, so only one, and we have the game object here. Pay attention now. If I hit the play button, we will load after 3 seconds our sample scene, and notice here we have the singleton and we have the singleton tester. And notice now when we go back, you see what is going on. Actually, now we are going back and forth from one scene to another scene, but I'm also going to pause the video or pause this program or our game now. But pay attention, what do we have here? So we have the singleton object here, and we have another singleton object here. Notice we have two. So we are not using our singleton design pattern. We're not using it. Why? Because we're not destroying the duplicate. So if I use it now here, destroy game object, if our instance is not equal to null, notice here, if the instance is not equal to null, meaning the instance is already pointing to this or pointing to this class right here, we are going to destroy the duplicate. So only one will remain. We saw that we now had two because we attached this script on another game object in another scene, but pay attention what happens now. If I go back in Unity, I'm going to clear the console. And here we have one singleton object. If I hit the play button, and if I go in our sample scene, I'm going to pause it. Pay attention here. We only have the game object. We don't have that other game object because, let me just go back here again. In another scene, notice we have the singleton tester. We have it here. Here it is. We have it attached on him. We have attached on him the singleton script. But if we go from our sample scene to our another scene, pay attention in the hierarchy. Pay attention now. We don't see our singleton tester anywhere. We don't have it. The reason for that is because we used destroy the duplicate. So if the instance is not null, we are destroying the duplicate. Pay attention here. And if I go back, if I unpause the game and go back to our sample scene, bam, we are back in the sample scene. Pay attention here. We don't have the duplicate. We only have the main camera. We only have the game object. And here is our singleton object. So he is here. We don't have a duplicate as we had a moment ago, as we saw and demonstrated. So this pattern here, this pattern allows us, and I'm going to comment this line of code out. This pattern allows us to have a single game object, only one copy of it. And why am I emphasizing only one copy? Why it is important only one copy? Well, usually a singleton game object is your gameplay controller or your game manager, and game manager can hold some important data for your game, such as high score or current coin count if you have coins in your game, because if you buy or use coin as a currency to buy things in your game, or counting the lives of your player. You can do that with a singleton as well. And then you need a single instance, or you need only one copy, because if you have multiple copies, they can have separate values. You get my point? So if you have here a public int life count, for example, and I'm going to hide it in the inspector because we don't want it to be visible in the inspector. If you have a public int life count and you have 10 copies of the singleton class, all 10 copies can have different values for the life count. One can have a value 2, another can have a value 5. You get my point. But if you only have one single copy of this class, so only one copy or one instance of it, then this instance can only have one value. If we say the life count is equal to 2, then life count is equal to 2. And we can do that, we can test it out. So here in the sender, we can do something like, we can say singletons dot instance dot life count, not life count is equal to 3. And we can say, for example, print, and we can say the value of life count is, and I can say plus, and I can say here, call our singletons and the instance of the life count. So we set the value to be equal to 3 in the sender class. We know that the sender is attached on this game object in our sample scene. And if we go in our receiver, which is in our other scene, and if we do the same thing, if we say print, the value of live count is, what do you think the value will be? Will the value be equal to 3 or some other value? Let's test it out. And we can say it in receiver, live value count is, and here we can say from another scene, so that we can know that this is printed from another scene. And here we can say in parentheses, so in parentheses, from sample scene, like this. If I go in Unity and clear the console, if I hit the play button, we will see here the value of live count from sample scene is 3. We see here it is equal to 3. If we go to our another scene, notice the value of live count is 3 and printed from another scene. We see here it is printed from another scene, which is our scene right here that has this game object that has the receiver attached on it. So we see we can carry our values from one scene to another scene to another scene throughout our whole game. So for example, if we have a game where we can select multiple characters, we can store in some singleton class, for example, game manager, we can store which character we selected in main menu, so that when we go in our gameplay, that character will be the one that we will use to play our game. You see for what we can use these singletons. Now this is just on top of my head. We can use them for a lot of situations. But essentially a singleton is a one instance, so only one instance. It's a static instance, which means we can use the name of the class dot instance dot, and now we can use public variables, public functions that we have here, and then we can access them without using get component, game object find. You saw how that was complicated, so it is much easier to use singletons. Now I know some of you who have software development background will be like, static variables, we don't use them, they are bad, no use. Well, Unity is a little different. Unity loves this singleton pattern and it works like a charm in Unity. So if you are from software engineering, just throw that away. That does not count in Unity game development, because in Unity, you can use a static pattern or static singleton pattern how much as you want, or you see the need for your game. And don't worry about it, Unity loves it. It's a common pattern in Unity. You can look that up on Unity official tutorials. They use it as well, and they use it in their projects that they have created. So I can back that up with Unity technologies. And as I said, Unity loves this. So using static singleton in Unity is totally fine, totally okay. Do not worry about that. I hope that I shed some light on this complex topic that I saw some students have troubles with. Now, it's pretty simple when you get a grasp on it. Simply remember it's one instance, so only one copy of this object can exist throughout your whole game. You use the destroy game object to destroy the duplicate if you have it. So if instance is not null, meaning it is pointing to something, it's not null, it has a copy, destroy that copy. Else, instance is equal to this, meaning to this class right here, and don't destroy the game object that holds this script after we load another scene. And then you can carry your values, your variable values, that is from one scene to another scene throughout the whole of your game, and you can reuse them on different levels, on different situations in your game. And that is how you can, for example, as I said, keep the score count, keep the coin count, select different characters, even weapons, so on and so forth. Fahir here from awesometuts.com. I will see you guys in the next video.